combination.
Why do you think that?
It says selections.
Yep, that's what I'm going for. Okay? So if it says select or if it says choose, then you should be thinking that what we're talking about is a combination. If it says the word arrange or put in a line, then you should be thinking about permutations. So, what's the information? What do we have here?
There are 12 marbles.
All right, 12 marbles. And what kinds are they?
8 are red and 4 are blue.
So if I've got 8 red and 4 blue. Now keep in mind, as long as we're not talking about letters and numbers, then we're presuming that these are not replaceable, identical, duplicatable. You know what I'm talking about? They're somewhat unique, even though they're the same color. So, how many different selections of 5 contain at least 4 marbles of the same color? So what we're going to do is figure out different scenarios where that could happen. Start with the red and pick an extreme. What could I put down for how many red?
You could do 5 red.
All right. So if I do 5 red, then how many blue am I going to have?
0.
So 4, 2, 0. All right. Now, since I'm only picking 5 marbles, that's an extreme. So what should I do? Go down or up?
Down.
So now I'm going to say 8, choose 4. Now if I choose 4 of the red, then what's going to happen with the blue?
4, choose 1.
Right, exactly. All right. Now, there's only the 2 kinds of marbles, so there isn't likely to be any other kind of configuration where I have 4 red and have at least 4. Now, if I go down and I say 8, if I say 3 red, well, does that make sense?
No.
No, because that doesn't meet the requirement of having at least 4. So what's the only other thing I can do?
8, choose 1.
If I have
And 4, choose 4.
8, choose 1, and 4, choose 4. That gives me 5 marbles, and 4 of them are blue. Now, can I do 8, choose 0, and 4, choose 5?
No.
Why not?
Because there's only 4 blue marbles.
Exactly. So this isn't even an option. So these are the only scenarios that are going to make anybody happy. And keep in mind, the scenario, the criteria, is that I have 5 marbles, but at least 4 of them are the same color. So both of these things have to happen in order to make that true. So I've got to multiply those together. And then there's this possibility, which I'd also be happy with, because it's 4 red and 1 blue, but I've got to multiply the 4 and these two together because they both have to happen in order to make me happy. These two both have to happen to make me happy. Now, then when I get those numbers, this would make me happy, this would make me happy, and this would make me happy. And in order to get the total number of things that will make me happy, well, then I add them all up. Try that. Tell me what you get.
$344.
Exactly. There should be 200. Let's see. What's the 8 choose 4? That should be 56. Nope, that should be 280. I wrote them in a different order. And nope, this should be 56. And then this should be 8. Is that what you got?
Yes.
All right. So, any questions about that? First step is identifying the question. The next step, and again, this is actually a pretty simple one, but a lot of times they're going to offer you 3 things and then some criteria that you have to meet. But at the end of the day, there's a whole lot of problems where they do this kind of thing where we have to just set up different scenarios. All right, cool? And see, here's the way it's going to work. When they're grading these, they're looking for this method. All right? So, again, you don't have to write what they have exactly, but you'll notice that we have written the 8 choose 4 and the 4 choose 1 and then 280. We have written this. So, keep in mind, even if it's pretty simple and you don't need to, like, you could do it on the calculator, you should write this stuff down because this is demonstrating a method. All right? Now, writing the letters next to it, I mean, that's, you could do it, but it's not required in order to get this point. All right? So, if you're doing some kind of 8 choose something and times 4 choose something, and then when the numbers add up to be 5, so what they're saying is that as long as you have 8 choose a number and then 4 choose a number, say it was 3 and 2. Even though that doesn't really meet the criteria, as long as these 2 numbers equal 5 and these 2 numbers up here are 8, then you're still going to get a point. And so, this is how method points work. It doesn't have to be perfect. And so even if you're not sure, like writing something down sometimes will get you the right thing. And then you'll notice here to get this, 2 correct outcomes. So you notice how there are 3 outcomes. If you just got 2 of them right, say you made a little mistake, then you could still get a point for having 2 of them correct. But you got to make sure they're all written down so they can see that. And then the third is that you would add them up. And say, for example, for some reason you didn't see this method or, this third choice, and you only added up to 2 of them, well, then you still could get this method point for adding up 2 or 3 different scenarios. And then, of course, you get the 4th point for actually having the right answer. So method points, in this case, the method was to use the combinations and have them make sure they equal 5, and then adding them up. That's 2 points out of 4 that you can get, even if you kind of screwed up a little bit. Take a look at number 2. How many different arrangements are there of 8 letters in the word released? So this tells you that we're dealing with what? Alexa, what are we dealing with here?
I'm not really sure.
Well, so we've got the last situation. Do you remember when they talked about choosing and selecting?
Yeah.
All right. How many different selections? If you see that, then you know we're talking about combinations. When they talk about this arrangements, numbers of arrangements, then you should be thinking that we're talking about permutations. That's a dead clue right there, okay? So we're talking about permutations, and what they do a lot of times when they have these words or the letters with words, we're going to rearrange these letters here, and they'll tell you how many letters there should be. They're not going to mess around. If they say there are 8 letters, there really are 8 letters. So, Alexa, what is the first thing they want to know?
They want to know how many arrangements
Exactly.
or how many can be arranged.
So, what can you tell me about finding the number of arrangements when I've got some different things here? What do I do?
I think first you need to see which ones repeat.
Yeah, I agree. I love that strategy. So, if it's me, I'm going to rewrite it. So, what repeats here with the word released?
The E's repeat.
Exactly. So, what I'm going to do is I'm going to rewrite the word with the things that are matching together. So it looks like this. Now, do any other letters repeat? And see here, I'm going to go like this. I'm going to mark this off and mark this off. and mark this off. And then if I'm not even sure, what I'm going to do is I'm going to write down the other letters. So I've got R, L, A, S, and D. Now, how many letters should I have?
8.
And count them. I got 1, 2, 3, 4, 5, 6, 7, 8. I'm feeling pretty good about the fact that I've got the right stuff. All right? Now, how do I arrange things? If I'm arranging all 8 of these, what am I going to do?
Would you put like the total number of letters on top of the equation?
That's exactly what I'm going to do. What's my total number of letters?
8.
All right. If I'm going to arrange stuff and I'm arranging all of the stuff, it's going to be the number of things factorial. That's never going to change. All right. Now, however, the duplicates I have to take into account. If this E and this E switch places, it's still going to be EE. And if this E and that E switch places, it's still going to be EE. So it doesn't really change any word I might have created. So what I'm going to do to take into account the duplicates is divide by whatever duplicated. So how many duplicates do I have here?
3.
And so I'm going to do 3 factorial. Now, in my calculator, I'm going to make it look exactly like this. I'm going to stack them up using that, that stacking feature, that fraction feature on the calculator, right below the option button. And what's 8 factorial divided by 3 factorial?
It'd be 6,720.
All right, so anytime you're arranging all of the things, you always do that number of things factorial. Especially, we're talking about no real, there's no restrictions. There's no things are making us to do, okay? Then whenever there's duplicates, whenever I'm arranging anything and there are duplicates, I'm always going to divide by the number of duplicates factorial. All right, so that's all there is for that one. In B, it says how many different arrangements are there of the 8 letters in the word released in which the letters LED appear together and in that order. So number 1, they're saying that they want to keep LED together and they want them to stay in that exact order. So Kayla, what would you do now?
I would first make spots, like draw 8 lines
Okay.
for the left.
1, 2, 3, 4, 5, 6, 7, 8. Right?
And then I'd write L, E, D in the first 3.
All right. L, E, D. Okay. Now what?
And then I'd circle them to make them like one object.
Yeah, I love that idea. Thank you. Perfect. All right, Alexa. Alexa,
Yes.
how many letters do I have?
There's a total of 8.
Okay, but now look at this. Okay, better question. How many things do I have if I count LED as one thing?
Would it be...
This is one thing. This is a second thing. This is a third thing. How many would I have altogether?
6.
I got 6 things, okay? Whenever they talk about a group, I'm going to talk about my group as being one thing, okay? Now, whenever I've got a group that has to stay together, what I'm going to do is figure out the number of ways they can be arranged. So, Kayla, how many ways can LED be arranged if it has to say LED?
3 factorial.
So now if I arrange this, it's going to say ELD. And it's going to say D.
Oh.
What does it have to say?
LED.
If it says, if it has to say LED, then how many different ways is that going to happen?
1.
Exactly. Now, if we take that out of the directions, if it doesn't say that they have to be in that order, now what are we going to do?
3 factorial.
Exactly. Do you see the difference? So sometimes when they put things into a group, they don't, like, this is actually a little bit unusual that they want it to stay together, but if that the process doesn't change. If they have to stay together, then and they have to be in this order, there's only one way that for it to happen. Whatever I'm saying is the first thing I do is like you did, I identify my group and I circle it. And the first thing as I write down is a number of ways they can be arranged. And then Alexa, I now count the group as one thing and I arrange all my things. So how many things are there?
There's 6.
6. Now, what are the things that are going to be over here? What letters? Now remember, there's an L and an E and a D over here. What letters could be over here? How many E's were left over?
There's 2 E's.
So I'm going to go like this. And again, it doesn't mean they have to, let's see, and the L is used, but the R is not. A, S. Are you with me on that? All right. This is one thing, and then, but altogether I've got 6 things, right? So how do I arrange my 6 things? 6 factorial. Now, are there any duplicates? Alexa, are there any duplicates?
There's the 2 E's.
Exactly. Now, the thing is, we don't say there are 3 E's because we're only counting this circle group as one thing. We're going to deal with them and their arrangements separately, which we already did. They can be arranged one way. So there are really, out of the things I'm arranging, there are only 2 E's that get duplicated. So what's 2 factorial divided by 2, or 6 factorial divided by 2 factorial?
360.
Exactly. Okay? Now again, if they had said to group these and they didn't say to keep them in order, then we would have done 3 factorial times 6 factorial divided by 2 factorial. The first thing I'm going to do is figure out the number of ways my group can be arranged. All right, so then let's see. What does C say? An arrangement of 8 letters in the word released is chosen at random. Find the probabilities that the letters A and D are not together. All right, so they use the word arrangement and they use the word chosen. Now keep in mind what's going to happen is basically think about this. There are a bunch of arrangements and we're going to pick one of them at random. So we want to know the probability of picking this arrangement where the A and the D are not together. So the first thing we should do is figure out, well, and we already figured out how many ways the letters can be arranged in total. How many ways can the letters be arranged in total? 6,720. So that's what I'm gonna divide by, because that's the total number of arrangements. So what we got to do now is figure out these arrangements where A and D are not together. So they use different words. Sometimes they're going to say these things have to be separated. Some things they'll say these things can never be together. So A and D can't be together. That means the same thing as being separated. So what I'm going to do now is I'm going to write down, I'm going to kind of put this A and D, and then all the rest of my letters are R, E, 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 L, S. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. All right. So AD. Now, whenever you have to separate something, we're going to start by putting the things that are going to be doing the separating. Here are the things that are going to be doing the separating. R, E, 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 L, and S. They're going to be separating the A and the D. The A and the D can go in any of these spots. If they are in any of these spots, well then they won't be next to each other. So start with the guys that are going to do the separating. They're always going to be the one you have more of. All right. Now we got to figure out the way that the non-ADs can be arranged. Kayla, how many ways can the non-ADs be arranged? How many ways can these guys be arranged?
The non-ADs?
The non-ADs, these guys. How many ways can they be arranged?
6 factorial.
6 factorial. And then again, whenever you're arranging anything, ask yourself, are there any duplicates?
Divided by 3 factorial.
All right. Now, that's how I'm going to arrange the R, the E's, and the L and the S. Okay? Now, what I got to do now is arrange. I'm going to put AD. How many places could I have to choose from? How many places do I have? 1, 2, 3, 4, 5, 6, 7. There's 7 possible places, and I'm going to take and I'm going to arrange them in 2 of them. So 7, P, 2. That's going to put the A. That's the number of ways where these A's go where any of these stars are. So tell me, what do you get when you multiply those together?
5,040.
5,040. All right, now keep in mind, this is a probability question, and you have to be careful because a lot of times in combination questions and arrangement questions, they just ask you for a number of ways. And other times, they ask you for probabilities. If they ask you to find a probability, you're going to start off by finding the number of ways, but you can't stop. So first, this meets the criteria of the A and D not being together. There's 5,040 ways for that to happen. This number right here is the number of ways that I could possibly have arranged the letters. So the way I find the probability is to divide these. What's 5,040 divided by 6,720?
3/4.
3/4, or we could say 0.75, right?
Yes.
Any questions about that? This deals with several of the things. This actually is a really good example of a good arrangement problem. They almost always, and like I said, I hate to say always, but almost always they start off with just saying how many arrangements are there. And I don't know that I've seen for a long time. Is it possible there'll be no duplicated letters? Yeah, but when we're talking about words, they almost always have at least one set of duplicated letters. And then they typically have you do something else with it. And the 2 major things is apply some kind of criteria. Oh, the M has to be at the beginning or the end, or the G has to be in the middle. That didn't happen in this problem. But then the other 2 is that they keep things together or they keep things apart. And so this one does 2 out of those, or 3 out of those 4 things. All right, so let's take a look at. Again, if you look for A, all they needed to know was the number of arrangements. They're not looking for anything crazy. If you know how to do this, this is going to take you seconds to do. Now, if you just write 8 factorial over 3 factorial, they're not going to give you the points. You have to actually write equals 6,720. Okay? Now, but again, that's only worth 1 point, but it's a pretty easy 1 point. Now, again, this next part you don't have to write this. You'll notice that we wrote something like it. We put ours in the beginning. The fact that they put theirs in the middle, it's irrelevant. But you can see they even used some kind of methodology that we did. But this isn't important. Like, I mean, yeah, it's not going to hurt. I would do it just because it makes the problem easier to do. But I don't want to give you the impression that if you don't do it, that you won't get the credit. If you just have this, then you're going to get it. And here you'll notice that if you do 6 factorial divided by something, or even 5 factorial times 6, which I'm not sure why that would be okay. I mean, you can still get a point if you misnumber the duplications. But there has to be a number down here. If all you do is 6 factorial, then you won't get the method point. But if you divide by anything, even if it's crazy, you'll get a method point. And then the other method point is, well, you know what? M is an integer greater than 5. Yeah, see, I don't get it. I mean, I'm not sure what that means. Anyway, third point is get the actual right answer. All right, let's take a look here. In the probability question, you can see where we've done kind of the same thing, but this is what we're looking for. And this is the method. They need to be able to see this method. If you're writing stuff, that can kind of explain to them that you know what you're doing. And that way, if you screw it up, then they'll still think you're using the method. And then you can see here we multiplied by 7 or P2. Say, for example, you screw up the first one. I mean, they'll still give you a method point. And then the probability. Even if you got the wrong number as the total number of ways and the wrong number here, if you at least try to divide them, then you can get a method point, because at this point, dividing them is the right thing to do. And then, of course, you get the right answer. All right. Now, this is different, right? This is tomorrow. Try doing tomorrow.
$3,360.
How'd you get that?
I did 8 factorial over 3 factorial times 2 factorial.
Alexa, does that make sense to you?
Yeah.
All right, so take a look at B. What's B say? Find the total number of different arrangements of the 8 letters of the word tomorrow that have an R at the beginning and an R at the end. So what do you think we're going to do? How are we going to approach this one? Alexa, what do you think we should do?
It says that the 3 O's aren't all together, so we could start by writing down all the other letters.
Well, now, let's read this. It says the O's are what?
They're not all together.
All right. And what else has to happen?
There's an R at the beginning and an R at the end.
All right, so how many letters are there?
8.
Let's start by kind of making a little patch. 1, 2, 3, 4, 5, 6, 7, 8. What goes here?
An R.
Exactly. And what has to go at the end? That
Another
takes
R.
care of this, right? Now, tell me about the O's. It says the O's. Now, we'll read this very carefully. What's it say about the O's?
The O's are separated.
See, that's not what it says. But I completely see why that's what you think it says. What this is saying, in a very literal sense, is that all three O's are not all together. What that means is they're okay with two of the O's being together. What they don't want to have happen is that all three of them are together. Now, again, take a look at the difference here. Here it says all three O's are not together. All three of the three O's are not all together. I guess that's the key word. If you go back to the other question, it says find the probability that A and D are not together. Now, there's only two letters in this case. So if they're not together, that means they have to be separated. Is that the only one that we've done so far like that? Yeah. All right. So this one is referring to all of them not being together. And so what we've got to do in this case is figure out how many ways it could be if they were all together. How could I figure out, what would I do if I wanted to know how many ways where all of the O's are together? What would I do first? Alexa, what do you think I'm going to do?
Will you write down all the O's?
And I'm putting them together. Are you with me on that?
Yes.
Okay, so let's break this up. What is always going to be in this first spot? Kayla, Alexa, what's always going to be in that first spot?
An R.
And what's always going to be in the last spot?
Another R.
And so there's only one way for that to happen, and there's only one way for that to happen. Yes? So what I got to do now is figure out how many ways the O's are these O's stay together. So what we're going to do is, but keep in mind at this point, I'm only arranging this area here. So I'm arranging three O's. How many different ways can three O's be arranged? Kayla, how many different ways can three O's be arranged?
Would it be like 3 factorial divided by 3 factorial?
Exactly. Because, I mean, there are three things. And if I divide by the three duplicates, what's it going to equal?
1.
Exactly. Okay? But your logic is perfect. This is true. That's why there's only one, because I'm going to divide by the duplicates, right? Now, Alexa, how many things am I, once I've figured out the number of ways to arrange my grouped items, what am I going to do now?
You find out how many things there are, and I think there's 4.
Exactly. We got 1, 2, 3, 4. Now we're going to arrange these 4 things. What are the letters that aren't R's and aren't O's?
T, M, and W.
Okay. Now the reason I want to know that is because Because if they were duplicates, if all I did was say, oh, there's 3 letters, and I did 3 factorial or whatever, or we'll say 4 factorial, well, then I may not notice that they're duplicates. Now, there are no duplicates, so how am I going to arrange my 4 things? What's that going to be? Just 4 factorial, right? And this is going to be 1. So what's 4 factorial equal to?
24.
Right, could be 24. All right, now, find a total of different arrangements of the letters in the word tomorrow where the R's in the beginning and the R's at the end, in which the 3 O's are not together. We just found out the number of ways where they are together. Now, what we've got to do, though, is figure out how many different ways we can arrange these things. Because remember, I don't worry about the R's. They're just going to be R's. In all of my arrangements, it's always going to start with an R and end with an R. So actually, there's going to be no variation in those at all. How many ways can these middle spots be arranged if the O's don't have to be together? Now how many things do I have, Alexa?
6.
And 6 factorial, because I'm arranging all of them. How many of them are duplicates?
3.
3 factorial. How many different ways can OOOTMW be arranged?
120.
So OOOTMW can be arranged in 120 ways, and 24 of those ways have all 3 O's together. So if I want to know the number of ways where all 3 O's are not together, I have to subtract 24. What's 120 minus 24?
96.
There you go. Okay? So, be very, very careful when we're talking about this thing of separation. If they talk about all of them not being together, that means that a couple of them could be together, just not all of them. And very often, if they have 2 things, they'll use those words not together. But if they have more than 2 things, they'll use the words separated. They have to be separated. Now, if those things have to be separated, well, then we're going to do like we did the last one with the lines and the bars and the stars thing. Any questions about that? Awesome. So again, here's the rubric. And again, it's pretty simple. I mean, this is what they need to see in order to get the points. If you at least do 8 factorial, and then there's something down here, and there's some criteria they have to go from, but you can still get a method point, and then you get the right answer. 2 points. You do the right method, you get the right answer. And then, what we say? B here, 6 factorial over 3 factorial minus 4 factorial. Essentially, that's what we did. And then here, in C, did we do C? Oh, we didn't do C. What's different about C? Kayla, what's going on in C?
That it deals with probability.
That's true. What else is happening? Are we arranging or are we choosing?
Choosing.
All right. So, again, from looking at a lot of tests, and I can't guarantee it's always going to be this way, but the pattern is typically they start with permutations, And then very often they'll end with a combination problem. And so you'll notice how they've given a separate set of directions here, and that's to let you know, okay, something's radically different. 4 letters are being selected at random. That means we're not arranging them now. Now we're selecting them, we're choosing them, but we're still doing this word tomorrow. All right. Now the trick is that tomorrow has got several duplicate words or letters. What do we got? 3 O's, 1, 2, 3, and 2 R's, and then TMW. Okay? Now, whenever you're doing combinations and there are duplicate things, then you have to really be careful and separate the different scenarios. Now, here's another thing. Now I wish I would have done this problem in a different order, but we're going to do this anyway. Okay, so let's do this. Here's the other thing is, like you said, this is a probability question. So we're going to do this a little bit differently, and I'm kind of going to try to explain that when we get to it. First, we got to figure out our scenarios. What's the criteria? They have to have at least 1 O, and they have to have at least 1 R. Then we're picking, what? How many? 4. 4 letters. So here we go to first scenario. 1, 2, 3, 4. So, Kayla, give me something. How can I meet this criteria?
You could do 4 O's and 1 R.
4 O's and 1 R. If I do
I
that...
mean,
oh, wait, I only need 4 altogether, right?
yeah.
So, but if I did 3 O's and 1 R, are you with me on that?
Yes.
That's one way to meet the criteria, yes?
Yeah.
What's another way to meet the criteria?
2 O's and 2 R's.
So, 2 O's and 2 R's. What's another way to meet the criteria?
You could do 1 O, 1 R, and a T and an M.
Oops, O. All right, so let's do this. 1 O, and then what'd you say, 1 R?
Yes.
All right, I'm going to leave these 2 spots but you're right, they're going to be either TM or W, right?
Yes.
All right. Now, what else can I do? Let's stick with our 1 O.
1 O and 2 R's.
That's another possibility, right? And then I would have 1 empty space for either T, M, or V, yes?
Yes.
Okay. Anything else?
No.
Let's see. 3 O's, 1 R. 2 O's, 2 R's. What if I had 2 O's and 1 R? Would that be okay?
Yes.
And we hadn't done that one yet, have we?
No.
All right. So now, here's the thing. If I am answering the question, not the question they asked, if I'm answering the question, how many ways can this happen? I'm going to do this differently than if the question is a probability question. So the first thing is, pretend it's not a probability question. Pretend that it just says, how many ways can I select 4 letters from the word 8 letters tomorrow if at least one is a 0 and one is of R? All right, in that scenario, what I'm going to say is there's one way for this to happen because I've already picked it. The O, the O, the O, and the R are all there. There's only one way for this to happen. There's only one way for this to happen. Because if I'm choosing 2 O's out of 3 O's, well, there's only one way. I mean, I'm going to get 2 O's no matter what I choose. So there's only one way for this to happen. Now here, again, I'm saying that in this scenario, there's an O and an O and an O and an R. And here there's an O and an O and an R and an R. There's one way for that to happen. There's one way for these 2 things to happen, but then there's some variation. How can I choose my last 2 letters?
3, choose 2.
3, choose 2. For this last 2, okay? Help me out. What's 3, choose 2?
3.
All right. Now, once again, in this scenario, I have an O and an R and an R. So that's not up to chance. The only question is, how many ways can I pick this last spot? So again, it has to be a T or an M or a W, and I have 3 to choose from, but in this case, I'm only picking how many?
1.
And what's that going to equal?
3.
All right. Now, in the last scenario, I'm saying there's an O here and an O here and an R here. And again, keep in mind, the order doesn't make a difference. The point is, I have 2 O's and 1 R. It could be in any order because we're not worrying about arranging. But then to pick this last spot, what's that going to be?
3, choose 1.
She choose 1. So that's 3. How many ways are there altogether?
11.
11 ways. Now, the thing is, in this problem, they want to know the probability. Okay? So if I'm going to find the probability, how many letters do I have? I need to find out the number of ways to pick 4 letters from 8. Are you with me on that?
Yes.
So how would I do that? How would I find out the number of ways to pick 4 letters from 8?
8, choose 4.
8, choose 4. Now, again, the problem in this case is that this is assuming that all those things are unique. Remember I told you when we're doing combinations, and if there are duplicates, we have to spell out every different scenario? Well, this could go on forever. There's all kinds of scenarios because there's way too many of these duplicates. So in this probability, so a good rule of thumb is if you're doing probability with combinations, well, first, help me out. What is 8 choose 4?
70.
All right, that's 70. But what's happening is this is treating every one of those letters like they're unique. Does that make sense?
Yes.
All right, so what's going to happen in a probability question, and now sound good again. So if this question didn't say find the probability, and all it said was find the number of ways, the answer would be 11. But the problem is if I divide 11 by 70, well, this 70 is counted, it's figured out a different way than I figured out the number of ways. So I have to figure out the number of ways the same way I came up with this 70. And that means I have to treat each one of these as if they are unique. So how would I fill in these O's? 3, choose 3. That's the number of ways that I would fill in these O's. How would I fill in the R? 2, choose 1. Does that make sense?
Yes.
And then how would I fill in these 2 O's? There are 3 of them, but I'm choosing how many?
2.
And there are 2 R's, and I'm choosing both of them. Now, once again, when I get to this one, I've got 3 O's, but I'm only choosing one of them. I've got 2 R's, but I'm only choosing one of them. And then again, there's this 3 times the 3 choose 2 for the last 2 spots, right? Here in this one, I've got 3 O's, but I'm choosing one of them. Here I've got 2 R's, and I'm choosing both of them. And then there's this last spot. And then here I've got 3 O's, and I'm choosing 2, and I've got 2 R's, and I'm choosing 1. So what's 3 choose 3?
One,
And then what's 2 choose 1?
two,
So I'm going to take this 1 for this, and I'm going to multiply it. So this is really going to be 1 times 2. Okay? 1 times 2, right? Now, what's 3 choose 2?
three,
It's going to be 3. And then 2 choose 2 is going to be 1. So this is going to be 1 times 3. Okay? Now what's 3 choose 1?
three,
And then 2 choose 1.
two,
And so this is going to be 6 times 3, because this part's not going to change when I do these. And then this is 3 choose 1 is going to be what?
three,
And then 2 choose 2 is going to be 1. And 3 choose 1 is going to be 3. So in this case, I'm going to do 3 times 1 times 3, which I'm going to do 3 times 3 is 9, right?
yes,
And in this last one, you already did it. What's 3 choose 2? You said that was 3, right?
yes,
And then this is 2 choose 1, so that's going to be 2. So this is going to be 3 times 2, and then times 3. So this is going to be 6 times 3. This is going to be 2, 3, 18, 9, 18. What happens when you add those up?
50,
And see, now that's what I'm going to put on the top of my fraction. The probability is going to be 50 divided by 70. Because I figured out the total number of selections, assuming that all of the things were unique, then I have to figure out the top number using that same strategy. If this problem had not asked me to find the probability and had just asked me for the number of ways, because if they asked me for the number of ways, the answer is not 50. The answer was 11. But if I want to know the probability, I've got to do find the top number this way and the bottom number this way. Does that make sense?
yes,
Alexa, you okay with this?
Yes.
All right. So again, you'll notice how they did the same kind of thing where they wrote down the letters, they have spaces, and then they figure out how to do the combinations and they do all that stuff, and then they divide by 8 choose 4. And again, you can see where you could get method points. Here, if you add 4 or 5 correct scenarios, then no repeated scenarios. You can still get a method point if you didn't, like for example, say you did this and you forgot one of these, you could still get the method point. If only 2 of them are correct, then you could get 2 out of the, what's the total points here? Was it 3 or 4? 4 it looks like. You could get 2 points just for getting 2 of them absolutely correct. Or I take it back, add 4 or 5, so they add them. All right. Now, take a look at 4 and see what you can do. How many different arrangements are there for the 11 letters in the word requirement? Alexa, what'd you get for A?
I haven't finished it yet.
Oh, I'm sorry. I'm going to write this down.
I'm not sure if this is right, but I got like 3,326,400.
How'd you figure it out?
Oh, sorry. What'd you say?
How'd you figure it out?
I separated the letters like you had, and then I did 11 factorial divided by 3 factorial multiplied by 2 factorial.
Nope, that's awesome. Is that what you got?
Yes.
All right. How many different arrangements are there of the 11 letters in the word requirement in which the 2 R's are together and the 3 E's are together? Try that one.
I got 40,320.
All right, so talk to me. How'd you do it?
I put the R's and the E's together.
All right, so I'm just gonna circle them since they're already together. Right?
Yes.
All right. So then what'd you do?
I counted all of the items, and that was 8 factorial. 8 items.
Yep. So you do it 8 factorial. Good.
Yes.
Now what?
And then I multiplied that by 2 factorial over 2 factorial times 3 factorial over 3 factorial.
Which both of those end up being 1, right?
Yes.
And again, think about it. How many different ways can I arrange 3-letter E's? Well, there's only one way. No matter how I arrange it, it's always going to say E, E, E. How many ways can I arrange R, R? Only one way. It's always going to say R, R. But you're totally right. I need to multiply times the number of ways the arranged things can be arranged. It just happens to be that in this case, they only can be arranged 1. So then what did you get? You said that was 40,000?
40,320.
Alexa, what do you think about that?
I got the same thing.
All right, that's awesome. Now tell me, how many different arrangements are there of the 11 letters in the word requirement in which there are exactly 3 letters between the 2 R's? So what do you think we can do about this? How can we better visualize it?
Would you just write the spaces for the 11 letters?
See, I think that's a great idea. So I'm going to try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now again, what's the requirement? What has to happen?
There has to be 2 R's with 3 letters between them.
All right, so, and there are only 2 R's, right? So let's start by putting an R here. Yes?
Yeah.
Now, if I start by putting an R there, then what else has to happen?
There has to be 3 blank spaces after that.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, this is a line. 1, 2, 3. Blank space. Now what happens at the 4th space?
You put an R.
All right. Agreed? Now, that meets the requirement, right?
Yes.
All right. Now, keep in mind, in all of my arrangements, in this group here, that R is always going to be there, and that R is always going to be there. What I got to do now is figure out how to arrange the other letters. How many non-R letters are there?
9.
So that's 9 factorial. And how many of them are duplicates? If we're not talking about R's, because we aren't, because the R's are already used up.
3 factorial.
All right. Now, for this one situation, there are 9 factorial divided by 3 factorial ways to set this up, where the R is always here and the R is always here. Does that make sense?
Yes.
All right, so let's do this. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If the R is not in the first place, where else could it be?
The second place.
And see, what's going to happen is I'm just going to go systematically. Now, of course, now, again, 3 empty spaces. 1, 2, 3. And where it happens here? An R, right? So
Yeah.
then what else is going to happen? Well, now I'm going to have 1, 2, 3, 4, 5. The R is going to move over again, isn't it?
Yeah.
And the R is going to move over again. How many different ways can I have it where the R's are 3 letters apart?
Seven.
Now, in every one of those cases, how am I going to arrange the other letters? Nine factorial divided by 3 factorial, right?
Yeah.
So if I take 9 factorial divided by 3 factorial and multiply it by 7, that's going to give me the number of ways this can happen. Does that make sense?
Yes.
So again, here's another situation where in their requirement, there are more than one way to make it happen. In this case, each time the arrangements will be the same way. I just got to figure out how many different ways I can move these R's around. And it turns out to be 7. So that's not too bad. But it's a weird one. Questions about that? You good? All right, so let's see. Again, you can see 11 factorial over 2 times 3 factorial. That's all they're looking for, and a number. 2 points. Part B, 8 factorial. They're looking for a number. 1 point. Here you can see where if you did 9 factorial divided by 3 factorial and then multiplied it by something, you would get a method point. If you multiplied 7, because that's the number of ways, I'm guessing times some integer. Well, I'm guessing what they're saying is that if you come up with a number of ways and multiplied, like if your 9 factorial over 3 factorial was screwed up, but you multiplied it by 7, you could still get that point. But then their total number is going to be this. All right. Now, take a look at this last one here. 5 of the 11 letters in the word requirement are selected. How many possible selections contain at least 2 E's and at least 2 and 1 R? Now notice in this case, they are not saying anything about probability. So what we need is the number of ways they can be selected. And again, Alexa, are we doing combinations or permutations?
I think this would be combination.
Exactly. Because you'll notice how they use the word, and like I said, I've just pulled these problems out of tests. They'll either use the words pick, select, but they love to use the word select. Now, when we say it, we like to say, well, we always say choose a lot of times. And so they won't always say that or whatever. They may say that, but they love to use the word select to let you know that you're doing a combination. Now, just again, like we talked about, how there's duplicates, and that causes a problem. How many E's are there? 3 E's. And how many R's were there? 2 R's. And so then we've got this other stuff. Right? Did I do that right? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I need to have, I'm doing 5 letters. 1, 2, 3, 4, 5. Alexa, give me a way to meet their criteria.
You could do 3 E's and 2 R's.
All right, so if I do 3 E's, now, if this is what's happening, there's one way for this to happen. Does that make sense? All right, what's another way?
You could do 2 E's and 2 R's.
Now, what do I do for this last empty spot? What cannot go in this last spot? An E or an R? Because what's happening is we're designating this scenario. What's happened in this scenario? In this scenario, there are 3 E's chosen and 2 R's chosen. So there nothing else can happen. Here, there's 2 E's and 2 R's chosen. So that means this last spot has to be filled by a non-E or a non-R. How many non-E's and non-R's do I have?
6.
So what I'm going to do is I'm going to do 6, choose 1, which is going to be 6. What else would make them happy?
You could do 2 E's and 1 R.
Because 2 E's and 1 R, because it has to have at least 1 R, right? And so now, what could go in this spot? Because what we've said right now is in this scenario, there's going to be 2 E's and 1 R. And again, we don't have to worry about counting that out. That's just going to happen. We do need to figure out how these other get chosen. How many non-E's or R's are there?
6.
So I'm going to do 6, choose 2. Help me out. What's 6, choose 2?
15.
And now, 1, 2, 3, 4, 5. Any other way to meet their criteria?
I think that's it.
So right now we've got 3 E's and 1 R. No, we got... Do we have 3 E's and 1 R?
Oh, yeah. You could do that one.
1, 2, 3, Now, here's what I'm going to tell you. Do you see when you did this one? Before you got away, because let's face it, it needs to have at least two E's, right? Now, before I got away from the three E's, and there are only three, so that means that's the most. What I like about the way you started was you picked an extreme. This is the most E's possible. And then you followed it up with the most R's possible. Okay? So then what I would say is before I move on, I would stick with the three E's and still see if there's some way that I could do three E's and meet the criteria. Well, I can still meet the criteria because there just has to be one R. So now there's six, and I'm choosing one for it. So that's going to be six, right? So now I've got 3 and 2 and 3 and 1. And then I go down to 2 and 2 and 2 and 1. 1, 2, 3, 4. Now, how many ways are there altogether?
28.
Now, I want you to again see the difference in this question. They've asked me for the number of ways. If they just ask about the number of ways, when you fill in these letters, you're not going to worry about choosing them. You just need to figure out how you're going to choose the empty spaces. However, if this had been a probability question, then I would have done 3 choose 3 and 2 choose 2 and 3 choose 2 and 2 choose 2, because what's going to happen is the bottom number in my fraction would have assumed that they're all unique. Does that make sense? So these are two similar questions. One's a probability and the other one just asks for a number of ways. How are we doing?
Good.
Good. Let me see what I got here. Before I go on, are there any questions that you had that you wanted to ask me?
So what all is gonna be on the test?
So the test is going to be over probability, permutations, and combinations. So we had that one paper with the probability questions, right? The one paper with the permutation questions, and then the other paper that had both permutation and combination questions. And then there are these questions that I'm showing you right now. And then there was a video I made from Tuesday that talks about probability questions. If you just worry about the ones that are on those papers that we talked about and the ones that are on these two videos, then you should be fine. I'm going to try to keep the questions similar to these kind of questions.
Okay, thank you.
And I'm also not going to make it like the other chapters. I had thought about doing that, but this is just going to be these two. And again, you can see when their rubric, this is the way they've got it laid out. Writing down the letters shows you understand the method. And so the nice thing is if you wrote the letters down like we did, then say, for example, you just copy a number down wrong, the person's going to at least probably more likely give you the method point because they're going to understand what you were trying to do. All right, so here I want to talk about this, but we're not going to do it. So take a look at this, because this is very similar to the ones we were doing. Find the number of different arrangements with the word jewelry, okay? Now, the 3 E's are together and the 2 L's are together. Now, what's weird about these questions that happen to have been picked, and again, I just grabbed some, but in all these cases, they're keeping together the letters that are the same, which is actually making the problem easier because you don't have to worrying about how they get arranged. Just keep in mind when you're keeping things together, you have to multiply by the ways they get arranged. And then here it says find the different arrangements where the 2 L's are not next to each other. How would you go about doing that? So here, let's do this. What are our together letters? E, 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 1, 2, 3. L, L, right? Anything else? J, W, R, Y. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters. If I'm doing this one, that's one group, that's one group. How many things do I have? 1, 2, 3, 4, 5, 6. 6 factorial. And this can be arranged one way, this can be arranged one way. This looks like it's just going to be 6 factorial, right?
Yeah.
All right. Then B, the 2 L's are not next to each other. So again, pick the non-L's. E, 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 J, W, R, Y. And then the L's have to go somewhere here. So how can I arrange the non-L's, Alexa?
It'd be, you could arrange them in 7 factorial over 3 factorial.
Exactly. Now, how do I put in the L's, where they go? How many places could I use, Kayla?
Eight.
And I'm only going to put in 2. Now, my L's are duplicated?
Yes.
So, what do?
Divide it by 2 factorial.
Whenever you're arranging anything, if they're duplicates, then you divide by that. So when I multiply those 2 things together, I'll get something. What will we get? 9 factorial, let's see. Oh, they did it. They subtracted it. Let's see if we get the same thing. What do you get when you do this? Oh, why'd I do this? 8P2, right?
$23,520.
Right. Now, notice what they did was they found the number of ways where the L's are together and they subtracted it from the total number of ways, but you get the same answer. So even though they have this on the rubric, this other method that we used is completely legitimate. Now, last
So
question.
wait, I have a question about.
Yep. What's that?
If we use that method on the test, will we still get method points?
Yep, exactly. What'll happen is, and I may not have put them all down here because of space, but a lot of times in the rubric they'll have alternative methods, and I may have just picked the first one. But no, like I said, there's nothing wrong with this method, and even if it wasn't listed, they would still give it. They would still. I mean, they would talk about it and like, yeah, that's legitimate, and they would give you credit, and so would I. All right, so the last one. Take a look at this. We probably won't even do it. I just want to figure it out. I got 8 pianists, 4 guitarists, and 6 violinists. 8P, 4G, and 6V, right? How many different selections? Again, selections. I'm now switching gears to combinations. Of 7 finalists can be made. So 7, it's like me selecting 7 people, but there have to be at least two pianists and 1 guitarist and more violinists than guitarists. Oh my gosh. So let's start with this. There has to be at least 2 piano players, right? So let's do this. 2. Now what?
There has to be at least one guitarist.
All right, so let's go ahead and make it 1 guitarist. Now, how many people are we picking?
7.
So then what has to go here?
4.
Now, what's the other requirement, though?
There has to be more violinists than guitarists.
All right, well, that seems like that works, right? So we've got 2 pianists, 1 guitarist, and 4 violinists. What else would meet the criteria? Let's stick with the 2 piano players. Is there any other way I can do it and meet the criteria?
2 guitarists and 3 violinists.
Because the only rule is I have to have more violinists than guitarists, right?
Yes.
All right. Now, if I'm sticking with the 2, is there any other way for this to work with the 2 pianos?
No.
So now is when I step up. It's not going down, it's going to go up, right? So now I pick a third. Now if there's 3 piano players, now what can I do to get 7?
1 and 4.
1.
I mean,
I need 7, so I need 4 over here, right?
yes.
So what would be here? What would I do?
1 and 3.
So if I did 3 guitarists, no wait, 1 guitarist and 3 violinists, right? Because I have to have more.
Yes.
Okay. Now stick with the 3. Is there any other way to make that work?
No.
All right. So now I only go to the 4. If there's 4 pianists, now what?
1 guitarist and 2 violinists.
And is there any other way to make that work with 4 pianists?
No.
All right. So now we've got 1, 2, 3, 4 ways. And see, now I had 8. So I'm going to do 8, choose 2. I had 4. 4, choose, 4, choose, 4, choose, 4, choose. And then I had 6. I'm going to get a number here. 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 And what's the total number of ways? I'm going to add them all up. Right?
Yes.
So, again, when we talked about this in class, if you're typing this in your calculator, and don't worry about it, you're going to do it right now. But if you're doing this in your calculator, I'm going to type this in. 8 choose C times 4 choose 1 times 6 choose 4. I'm not going to do them separately. I'm going to put them all in one line. I'm going to get a number. Then what I'm going to do is I'm going to go back to it, and I'm going to change that 4 to a 3 and that 1 to a 2, and then I'm going to find the next answer. And then I'm going to go back to it, and I'm going to keep this a 3, and then make this a 1, and make this a 3, and then find the new answer. I'm not going to do these separately, and I'm not going to retype this every time in the calculator. What happens is, I know it seems like a lot, but if you go back and use that function in the calculator where you just use that back key and then change the couple things that need to be changed, you actually can do these 4 things pretty quickly. And then all you got to do is add them up and you get your answer. All right, before we go, any questions?
Nope.
All right, did that help a little bit or no? I hope it helped. Tell me it did, because you know.
It helped.
All right, that's good. All right, so when you're looking over the other stuff, like I said, if you're looking over the other stuff, if you have any questions, well, like I said, focus on problems like we did here, problems like are on those papers, and then take a look at that probability video. Focus on those kind of problems. If you can do that kind of stuff, that's kind of what things I'm going to want you to do on the test. All right, cool?
Cool.
All right, thank you very much for coming. Have an awesome night. We'll talk to you later.
You too.
All right.